In this tutorial, I'm going to show you how to turn this into this. Hi, my name is Kaze and welcome to another Right Brain tutorial. So originally this tutorial started out as a top 5 best cool little free apps that you should know about. However, one of them caught my attention so much that I thought, man, this deserves an entire tutorial all for itself. And that is JSplacement, because it generates really cool displacement maps that you can apply to really simple geometry to create incredibly complex scenes like what you just saw in the intro. So basically, a displacement map is nothing more than a grayscale texture that you apply to your geometry. And the renderer looks at the grayscale values, and if it sees anything that's 50% gray, then it doesn't affect the geometry at all. However, anything that's moving closer towards the white value, it raises up, it basically extrudes upward on the normals of the geometry, while anything that's leaning towards the black values gets extruded downward. Now when it comes to displacement, any grayscale image will do. However, if you're trying to do something that's kind of futuristic, that's got like a lot of greebly surface, very complicated kind of shapes, say like the surface of the Death Star, for instance, right? Well, then in that case, a grayscale image of your dog is probably not going to do the trick. What you really want is a series of very, regular kind of geometric shapes like rectangles or squares or circles or lines and things like that, right? That's going to give you that kind of very futuristic sort of surface. Now, it used to be that you would do this in something like Photoshop or Illustrator. You would just open it up, you start drawing like rectangles and squares and lines and, give them like different kind of gray values and then export it as a TIFF and kind of hope for the best. However, what if I told you that you don't have to do any of that and there is a free application that will do all the hard work for you and come up with incredibly complex displacement maps literally at the click of a button? Well, that app exists and it's called JSplacement. I'm going to post a link below in the description with this website, but this is where you can get JSplacement. As I said, it's completely free, and what's best is that it's available for Windows, for macOS, and for Linux, so no matter what platform you're using, you're covered. So this is what JSplacement's splash screen, or this is what happens when you launch JSplacement after you download it, and if you click on it, you don't really get anything, because what you really need to do is click on this little square right here, and that gives you all sorts of really cool options. So we have different modes of JSplacement. I'm just going to give you a quick run through of what they do so you have a general idea. So we have JSplacement Classic, and if we hit the R on the keyboard, it will automatically generate a pattern for us, and every time you hit R again, it will generate another random pattern. So the Classic mode generates very regular sort of rectangles and squares and lines and, and some of these kind of stripes, but everything is very regular, and this comes in handy, if you're maybe doing a spaceship that's got like metal plating or something like that, but can also come in handy for cityscapes and that kind of stuff. So the second mode is JSplacement 2. So basically the second mode creates a bunch of more futuristic looking shapes, more kind of electronic-y sort of things. It's a little more intricate. This can be really cool if you're trying to make like a very futuristic surface, or or maybe even like a microchip or something like that. It's a little more intricate. It's got more interesting shapes, and and once again, like every time you hit R, it's going to automatically generate a random pattern for you. JSplacement Velvet is basically a very symmetrical, almost like a kaleidoscope sort of effect, and this can come in handy for certain things. And one of the nice thing about this particular pattern is that it's tileable. Actually, I think like they're all tileable, honestly. So but anyway, then we have JSplacement Wire, which you guessed it, kind of like does a bunch of like kind of little wires, and like it's just mostly kind of defined by all these lines that are created, and they also kind of have like a bit of a semi-symmetrical sort of vibe, but not quite. And last but not least, we have a really cool addition to JSplacement, which is the dot grid. And what dot grid does is generate a bunch of dots, which can be really useful if you're trying to do like a cityscape and you want it to look like there's a bunch of little windows in your buildings and each window has a light behind it, right? So even if you're doing like a massive spaceship, this can come in really, really handy if you're trying to convey a really huge sense of scale. So this is really, really cool stuff. Now for this particular tutorial, we're going to be sticking with the JSplacement Classic, okay? We're going to be generating some maps through this guy because I want to use more kind of like regular rectangles and regular geometry, but of course I would encourage you guys to experiment with JSplacement and all the different maps and all the different modes that it can come up with. So on that note, let's save this guy. So I'm gonna say save height. The height is basically what's going to drive the displacement, and I'm just going to call this JS height. I'm going to call it main. And the nice thing about JSplacement is that it produces 8K maps, so you have a lot of resolution in there. The only thing that I wish it could do is save as EXR, maybe in some future version of the program, but right now it's using PNG, which should be fine. Okay, the other thing that I want to do is with the same pattern, so make sure that you're not changing any of these parameters or you're not hitting the R key on your keyboard. Using the same parameter, I want to use some color so that I can use it on the surface of my object. So if we hit this toggle colorizer button right here, we'll see a bunch of cool, interesting gradients, and if we click on them, you'll see what they do. They give us like a bunch of different interesting sort of variations of colors. For my particular purposes, I don't want anything that's a little too crazy or bright. I'm gonna go with this guy that's gonna give me more of an industrial, it's kind of like some grays, some browns. I'm gonna click on the save color right here, and it's gonna ask me what I want to save it. I'm just gonna call it JS color, and also I'm gonna call this main, okay? Okay, so having said that, we're about to hit the R key once more and completely obliterate this particular pattern and create a brand new pattern. So I'm going to do that. As I said, make sure that you have all the maps that you're going to need exported with this same pattern. We're going to hit R again, and okay, and this one I want something that's a lot more complicated and kind of even like smaller, so I'm just going to push the iterations a lot higher to maybe like around 1500. Let's go all the way up, and let's go to, let's see, if we click randomize, maybe the randomize button gives us something more interesting. Let's try that. That's kind of cool looking. So what I'm going to use this is not for height, but actually for my roughness, okay? So we're going to have a little bit more interesting sort of patterns on top of our displacement itself. So I'm going to click on save height because I don't need the color information for this. So I'm just going to click save height, and I'm going to call this JS roughness main. Okay, there's one more map that I want out of JSplacement, and after this I promise we'll move over to Houdini and get into the really fun stuff. So this one I want to use to punch out the opacity of my material so that we'll kind of see through the geometry, and this is going to come in really handy, you'll see, when we do like maybe some layer geometry to kind of give a real sense of depth in there. So I'm going to click the R button to generate a displacement map. However, this is way too complicated. I need to simplify this because right now it's just too crazy and I don't really need all this craziness for an opacity map. So let's bring the iterations down considerably, maybe something like 60, maybe even lower. 20 is good. I'm going to push the background brightness a lot, and then what I'm going to do is I'm going to clamp these rectangles so that they get as close to pure black as possible, because all I really want is a value of white, which represents no opacity, and a value of black, which represents 100% opacity. Clamp down the lines, bring down the maximum amount of these guys, and let's see here. This is pretty good. I'm liking this. I think this is going to do the trick for us. So I'm just going to save this, and once again I'm going to save the height, but we're not going to use this as a height displacement. We're going to use this as an opacity map. So I'm just going to call this JS opacity, and that's it. I'm going to click save. I think that's all we need out of JSplacement, but I'm going to keep it open in the background just in case we need to come back to it and generate some more maps. Alright, so here we are in Houdini. Now before we move forward, you should know that I'm going to use a render engine called 3D Light, which I really like a lot, and I'm going to post a link somewhere in here. I'm going to post a link in the description, and you should check it out because it's really cool, and best of all, it's actually free up to 12 computing threads, which a lot of people, like, that should be plenty. So definitely check out 3D Light. However, I know a lot of you guys are using Redshift, and some people might be using Arnold, and some people are even using Mantra. So at least for Redshift users, whenever I use a node that I know it's what it's called in Redshift, I'm gonna maybe put a little text on the bottom of the screen so you kind of see what the equivalent is. Arnold should be very similar. The process is really similar between all these different renderers. But hopefully this video should give you like an idea of what the process is, and then you can kind of adapt it to whatever render engine you're actually using. So the first thing I want to do is let's create a grid. I already have like an HDRI light set up here, and I have a camera already set up just to save us some time. I'm just gonna now create a grid. Okay, and let's jump in the grid. Let's maybe make it a little bit larger. Right now it's 10 meters by 10 meters. Make it like, I don't know, 20 meters by 20 meters, just to give us a little bit of room, so to speak. What we do need, however, is some normals so that the displacement maps knows where to push up and where to push down. And also we need a UV map because we don't have one. And if you've seen my tutorial on UV maps, then you'll know that on something as basic as a grid, we can use the UV project node. Now we want to create a material, so I'm gonna jump into my material context. I'm gonna use a 3D Light material builder. If you have Redshift, you would use a Redshift builder, a material builder, and Arnold, and so on and so forth. Anyway, you know the drill. And let's dive right into it. This terminal would be the same as like an out node. Normally, I'm just gonna put a principled, which for Redshift users is the equivalent of a material node, and then I need to import my textures. So let's start with the height texture. My height main texture that we generated in JSplacement. Cool. Can select that, say open, and what I'm gonna do is in 3D Light I can put it right into the bump normal displacement input right here under the normal displacement bump value. I just need to then change this from bump to actual displacement. 0.5 center will do the trick. If you are in Redshift, then what you would do is you would pump this texture into the displacement node, and then the displacement node could go into like the displacement input of your RS material node. But as I said, hopefully it's fairly clear if you're using a different renderer, but definitely check out 3D Light. Alright, so the last thing I need to do is assign my material to my grid. So I'm just gonna click surface 1, and hey, look at that. We have displacement. Oh, there's one more thing. If you're a Redshift user, you're gonna have to go into the Redshift tab. That should be somewhere around here, and enable displacement, or else you won't see anything. So let's put some color into this guy. So let's bring in another texture, and let's point it to our color main texture. This is our muted palette. Remember this, we're just going to use this as a general kind of building colors or whatever these greebles are. So I'm just going to put this into my color input. So we have color and we have height. What else do we have? We actually exported another texture map. That is our roughness map. So let's grab that guy, and here's our roughness. And our roughness is a little bit different. As a matter of fact, let me get rid of the displacement. Here, I'm just gonna fire up the IPR again. Cool. Let's just kind of pump our roughness into the main color, so you'll kind of see a little bit what we exported here. If you remember, so that's what it looks like. I think I'm gonna have to like kind of clamp this down a little bit because it's a little too grayscale, like it's a little too kind of generic gray, and I don't think it's gonna give us a whole lot of variation in our roughness of the surface. So let's take a remap node. As I said, like if you're on Redshift, then you would use a ramp to do the same exact thing. We can put the color into our input value. Actually, you know what? In this particular case, I'm just going to put like the green, the red, one of the channels into our input value because we're mostly dealing with just a grayscale value. We don't have any real color information anyway. So, okay, cool. And what I'm going to do is instead of going out of the color, I'm going to go out of value. Don't let this confuse you. This is just something that 3D Light does, which is differentiate between color, RGB, color information versus float, of which tends to be like values from 0 to 1 and anything in between. In Redshift, you don't have this, so you can just kind of go out of the main output of whatever node you're using, and Redshift will understand you know, what information it needs to grab from it. So as I said, if you're using like a ramp node in Redshift, you can just, you know, insert it into like the path and you'll be fine. However, 3D Light is a little bit different. It wants to give you some additional flexibility. So as I said, it differentiates the color output versus what it calls the float outputs, which are the individual channels. And in this particular case, we just need one individual channel because it doesn't have any color information, as I said. So let's start moving this guy and see what we get. I'm just gonna brighten up my white values, and I'm gonna darken up my dark values. I just want to basically create something that has a little bit more contrast. I suppose I could use like a color correction node for this as well. But as I said, for me, using the Remap node is a lot simpler in 3D Light, and I think using like the ramp node in Redshift also is a lot simpler. I'm going to make the IPR a little bit larger, so hopefully you can see a little bit better what I'm seeing. So let's see here. I am getting really close to my surface, so you can kind of see that what this other map that we created in JSplacement is doing is making some portions of my surface rough and some portions a little more shiny. And if I kind of clamp this guy down a little bit more, you should start seeing it. Actually, you know what? Let's get rid of this guy, and I'm just going to put like a black texture and very dark gray, and that should help us see a little bit better what's going on here. So you can see that as I am adjusting my little remap functions, I can kind of make things duller or more shiny depending on where my map has white values, black values, or gray values. Okay, so for instance, right now everything is fairly shiny except for like this kind of strips that are a little bit more rough, or I can make things a lot rougher. Okay, so let's just kind of play around with it until I get like a bit of, I don't know if I want anything to be like really shiny. I'm just looking for like some roughness variation here, just to kind of give us a little bit more of an interest in the surface. So this is kind of cool. The other thing I can do is I can actually maybe change the UV repetition, so that the scale, so that you know, maybe it's a lot smaller, these little variations in roughness. So let's do that. I'm just gonna put a UV node in 3D Light. Once again, in Redshift you don't need it. It's actually part of the texture node, but same difference. We're just gonna maybe like kind of put a value of 5 in here. So it's just gonna make the pattern a lot tighter, and we can go even like 10. I don't know. Nah, I think 5 was fine, so that we can see like the difference. So yeah, I mean, if you can kind of see, if we look at against like the kind of shininess, or like if we get like close enough to the edge, I'll just show you. This is without the roughness material, and this is with the roughness. We just have like a little more variation into like the type of surface. So variation is good. right? Because real things are always varied. So, all right, so here we are again. I re-enabled my displacement, and you know, I think we got like something that's really interesting. And once again, we didn't have to do a single modeling thing. It's just using the displacement maps and the other maps that we generated from JSplacement. There's another thing I want to do, however, that I forgot. So good thing we left the JSplacement open, because we're going to need to generate yet another map. I want to put some lights in here. I want to make it look like the surface is just like, I don't know, there's like places that people are living inside this weird kind of boxy world. So let's go back into JSplacement. And this time we want to go into our dot grid and hit the R button again, and we're just gonna generate some lights. Okay, so I mean, honestly, you can kind of completely go crazy with this, but you know, hit R a bunch of times. But I mean, basically any of these will do the trick. This is kind of fun. It's got like some kind of weird stuff going on there. And let's create another texture node. All right, and we're gonna call this Emission. And I'm just gonna point it to my new emission map that I just generated. And this guy, let's see, I'm gonna put it into the incandescence multiplier. Although if you're in Redshift, I think there's an actual emission input that you probably wanna plug it into. Right now we can't really see anything because my emission or incandescence is right now set to black. And the intensity is, well, intensity is set to 1, but it's black right now, so we can't really see anything. However, if I change this to white, then we'll start seeing some lights. Look at that. Can you guys see that? Let me pump this value up to like 25. So yeah, like, I mean, we are seeing some lights. As a matter of fact, if I go under my main environment light and I disable this so that we'll go completely black, you'll see. Now this is all emission, so and I can actually change the color of these lights. So right now we have white, but I can kind of make them red, I can make them blue, I can make them really any color that I want. So let's actually bring back our environment light so that we can see a little bit what's going on. And I don't know, maybe orange, which might be kind of fun. Maybe not quite as saturated. So it's like a little bit orange. You know, like a little bit like those tungsten-y sort of lights, but not too crazy. All right, so what else are we gonna do now? We have one more texture that I exported from JSplacement, if you remember, and that was like an opacity layer, okay? An opacity texture, and let's bring that in. Just gonna click texture, and I'm gonna call this opacity. All right. And I'm going to click on this guy, and there's our opacity. Remember, it's just white and black and really simple. It's got these big squares, and that's all we're going to need for what we need to do. So basically what the opacity means is that anything that's white, we want to see that, and anything that's black becomes basically transparent. So let's see, 3D light has an actual opacity input, and I can kind of punch this right into there. I'm going to go from any one of those channels. I think in Redshift it's called transparency. Once again, like I'll put a text somewhere on the screen so you'll see a little bit what the equivalent in Redshift is. So pumping this opacity, you can kind of see a little bit what's going on here. Now we have holes in our geometry, which is kind of neat. Right now they look kind of stupid. Also, we have emission. So let's do a couple of things. So the reason why I wanted to bring in this opacity so we can actually kind of punch holes in our geometry somewhere is because I wanted to have a sense that there's multiple layers. But maybe what we can do is not have the lights everywhere. By the way, shit, like I'm like all over the place today. I'm sorry, I apologize. I'm a little bit scattered, but I'm getting like new ideas literally as we're working on this. So this is gonna end up being a bit of a long tutorial, but I don't know, hopefully you'll learn a few things that you didn't know before. So right now the problem with our opacity is that it just knocked out portions of our geometry, but our emissions, our lights, are still being pumped through that. We want to be able to not have the lights where we have holes in our texture, and an easy way of doing that is to actually use a multiplication node. Okay, so the 3D light node that's going to allow me to multiply these two textures together is actually called the float blend. Redshift actually has a multiply node, so you Redshift users will probably going to be using that node. But basically it does exactly the same thing. I mean, this float blend just has all these different kind of options, and I want to choose multiply. The reason why we want to multiply these two textures together is because, keep in mind, on a grayscale texture, the value of black equals 0 and the value of white equals 1, and then you have everything in between, right? So whenever you have 1 multiplied by 1 gives you 1. However, when you have 1 multiplied by 0 gives you 0. So basically what we're telling 3D Light or Redshift is that anywhere that we have a value, a white value on the opacity map, which is 1, remember, then we want the emission to also have that value of 1. And anywhere that we have a value of 0, which in our case we're using to actually kind of create these transparent regions, then we want the emission to multiply it by 0, which in turn makes it 0, which makes it disappear. So let's see if it works. I'm just going to pump the red channel into the foreground. I'm going to pump the opacity red channel into the background. I'm going to pump this out to the incandescence multiplier, and if I did my job right, we will see that we now have lights only wherever our surface is being displayed, and anywhere that we actually have transparency into our surface, we have no lights. So we fixed that issue by using a multiply node. And as I said, Redshift works exactly the same way, and Arnold works the same way, and Mantra should work the same way, although in honesty I never really used Mantra. So I think we're basically done with our texturing. I mean, we have this kind of interesting displaced surface that looks like we did a lot of work, but we actually didn't really do that much. JSplacement did all the hard work for us. We have lights, we have different colors. I mean, it's kind of cool. It looks interesting, right? I mean, why not? However, the reason why I wanted to use an opacity map so that we can kind of make some portions of our surface see-through, transparent, is because I thought it might be kind of fun to give it like multiple layers, okay? As if like this is, I don't know, maybe some sort of space station that has like some portions of it that are like kind of lower and you can kind of see through. So let's do that. Let's take our grid, and I'm just gonna option click and duplicate it, and I'm gonna call this guy top, and I'm gonna call this guy bottom. Okay? Sounds kind of sexy. Come on, you dirty minds. I can't believe you guys go there all the time. The other thing I want to do is I want to duplicate my surface material because I don't want the holes into my bottom layer, and maybe I want to also change the amount of displacement that my bottom layer takes versus the top layer. So I'm just going to once again option click, and this is called, and let's change this. I'm going to call this top layer, and this bottom once again. Okay, cool. So, and I'm gonna, the top layer gets the top, but the bottom one, I want to assign the bottom material. And the main difference right now is that I want the bottom material not to have any opacity. So I'm just gonna take this opacity guy, I'm just gonna delete it. And the only other thing I want to do is, obviously I want to offset my bottom layer, so we're just gonna put it, I don't know, 5 meters below. I don't know if you can see, but we have some holes in our top layer, and then we have another layer on the bottom, and that's kind of giving us some interest. And what I can do in addition to that, here, let me just kind of maybe give us a little bit more light. This is going to be really bright, but at least we can see a little bit better what the hell we're doing. So maybe that bottom layer, I can kind of make some changes, just to kind of make it a little bit different. So on the bottom layer, the first thing that I want to do is I'm going to add a UV node onto my color. In Redshift, you don't have to do that because you can change the UV scale directly and rotation, all that kind of stuff directly into your texture node, but 3D Light wants a separate node to transform the UVs. As a matter of fact, I think Octane does too. So let's just maybe like kind of make this, give it like 5 and 5. And I'm also going to do the same thing with our height. I'm going to pump the same value, the same scaling value. But here, let's do something. Let's temporarily get rid of our top layer so we can just see the bottom layer, and we can kind of see a little bit what's going on here. So you can see that our bottom layer is just a lot. You know, like the textures are just like kind of being squeezed. That there's more repetitions of them. So because of that. It just looks crazier. It looks like some sort of, I don't know, like one of those very, very thick urban kind of, you know, photos that you see from like satellite photos or something like that. The only other thing that I want to do with this bottom layer is maybe make the buildings taller. So let's go in our displacement value, which in 3D Light is right into our principal material. In Redshift, you would find it under the displacement node. And let's change the intensity maybe to 5. It's gonna go a little crazy. Maybe let's make it 3. Yeah, let's go 5. Why not? Let's go 5. So it's got like skyscrapers. So if we re-enable my top layer now, you'll see a little bit what we're doing. So this should be able to kind of show us exactly what we have here. So we have kind of like this sub-layer that's got a bunch of skyscrapers, and then the top layer is maybe like not quite as tall buildings. So basically what I did in the video that I showed you at the beginning, I wanted to kind of make this feel like almost like some construction that's like really long in space. So all I did is literally just kind of make the grids a lot longer. So it's right now it's like 20 meters wide. I think I made it about 100 meters long. So it's like that. Same thing with the bottom. Just kind of change the sizing here. So yeah, so basically you almost kind of have like this kind of weird runway thing, but it's got like these gaps, so we can kind of see that there's more layers to it, there's more depth to it. And all I did is just create a some animation for my camera so that it was like, well here I just pointed the camera like so, and then what I did is I said keep position when parenting, and I added a null. And the null, I just wanted to move forward in Z space, right? So that would be like this guy. Actually, it's negative Z. Look at that. So all I did is, if you remember my tutorial on $F, that's exactly what I used. Except if I use $F right now, you'll see that we're actually going backwards, and that's not at all what we want. We want to be moving forward. Here, let me give it a little bit more space. Yeah, so $F by itself is not going to do the trick. So what I want to do is I want to have it go the opposite way. So all I have to do is just multiply by a negative value. And if I say multiply by -1, now we're going to be moving into the negative Z space. So we're going to go the right way. And well, here, let's see. Can I get like the IPR to march along with us? Maybe make that a lot smaller and half resolution. Let's relaunch it. See if we can get like some real motion. This is like really crazy low resolution, but hopefully it should kind of be able to keep up with our animation so that we can kind of see a little bit what it feels like. And I think right now it's going to go a little too crazy. It's a little too fast. So what I'm going to do is I'm just going to change this multiplier. Instead of -1, I'm going to put like -0.2. So that should kind of make it go a little bit slower. Okay, cool. I think that's about it. That's all I think I added a little bit of kind of wobbly motion. Once again, I did the tutorial for my shaky cam, I'm going to post the link somewhere in there if YouTube will allow me. And I did the motion effects, and so what this is going to do now is if I hit play, my camera is going to be, but it's a little too nervous right now, so I'm going to put like the amplitude lower, but I'm also going to put the roughness considerable, so it's a little bit, actually like the amplitude can be even bigger. Right now the IPR is going crazy, but you get an idea of like what the motion is going to be, but you know, like once we render it out, it's going to look fine. But that's about it. I mean, I used the Houdini to AE little add-on. If you watch my tutorial on that, you'll know how to bring your camera information from Houdini into After Effects. Okay, so here in After Effects, I just brought in my full resolution render. And all I did is just basically just kind of add, if you go to nasa.org, you can find like some really cool kind of photos of the upper atmosphere and different planets and stuff like that. So I just kind of put that in the background. As I said, I imported all my camera information from Houdini using the Houdini to AE add-on. And that way I had like the same motion happening in the background as my camera. And I think I added some lens flares and a little bit of glow, and that's about it. And that's how I got this kind of sci-fi-ish kind of shot. Alright, I think this tutorial's gone on long enough. Probably longer than what I originally intended. Sorry about that, but hopefully you picked up a couple of tricks from watching it. Most importantly, I wanted to show you guys just how cool JSplacement is and how you can use it to generate not just displacement maps, but other types of maps that then you can use to make your projects more interesting. Anyway, thank you for watching. Thank you for sticking it out this long. See you next time.